All right, welcome to lesson 3 of Every Question Explained in the SAT Blue Book. I'll be going through hopefully all 8 practice tests over the next few weeks, and I encourage any student who's actually studying for the test this summer to follow along with me. College Board released all 8 tests completely for free, and if you check out the description, you can get a link to all of the PDFs. Today we are on practice test 2, and we'll be running through both math sections. We're going to start with section 3, which is no calculator, and then hopefully we'll get to most of the calculator section as well. If you were here last week, and if you're familiar with the SAT, you know that the questions get harder and harder as it goes along, so you can go ahead and speed through it. What's up, Bob Gills in the chat? Repeat viewer from Tuesday. So follow along with me. You can go ahead, you can reveal some questions or some answers in the chat. That's totally okay, because we'll be going through step by step every single question. As far as streaming schedule goes, I'm going to be on Sundays, Tuesdays, and Thursdays from 7 to 9 p.m. Eastern. So if you can't make it, all the videos will be posted on the Allen Mentoring channel. But if you can, come on live and you can ask questions and I can address them right away. So let's get started with question 1. If 5x plus 6 equals 10, what is the value of 10x plus 3? So first I want to solve for x. So I'm going to rewrite the first equation here. Okay, I'm going to subtract 6 on both sides. Remember, with algebra, you want to do the opposite to both sides. So what's happening to 5x? It's being added by 6. I just want to do the opposite to both sides. So I'll subtract by 6 here. These cancel out, and we get 5x is equal to 4. So with this problem, actually, I can go 2 ways. I can either solve just for x, okay, isolate it, and then plug it back in here. But actually, what are they asking me for? They're asking me for what is 10x plus 3. Well, look here. I know that 5x is equal to 4, right? So 10x must be equal to 8. Okay, 10 is going to be double of 5, 8 is double of 4. So if we know that 10x is equal to 8, what is 10x plus 3? That's going to be equal to 11. Bam. All right, hope you're following along. If you have any questions, feel free to write in the chat. Question 2. Which of the following ordered pairs xy satisfies the system of equations above? So in this problem, usually I would solve it by showing you either substitution or elimination, but Bob actually asked on Tuesday if plugging in is a legitimate way to solve these problems, and I say absolutely yes. If you can plug in, it's probably the fastest way to solve a problem, and remember, your goal is not to show all of your work, it's to get the highest score possible. So in this case, I think the fastest way would just be plugging in each of these values and seeing if they equal 0 in the first equation and 10 in the second one. So let's plug in 3 and negative 2. Well, I already see that 3 plus negative 2 is not equal to 0, so I'll cross this out. 2 plus negative 2 is equal to 0, so this could work. Negative 2 plus 2 is also equal to 0, so this could work. And negative 2 plus negative 2 is not equal to 0. So I can cross D out. And so really now I have to plug in these two into the second equation and see if it equals 10. So let's do that. Let's plug in 2 and negative 2. Okay, so 3 times 2 minus 2 times negative 2. What does that equal to? 3 times 2 is 6. Minus 2 times minus 2 is plus 4, right? When you're multiplying 2 negative numbers, you get a positive number. So that's going to be plus 4, okay, which is equal to 10. And if this is not your first stream, you know that I'm really bad with 4s. For some reason, as I draw them, they turn into 9s sometimes. So I'm going to be cognizant and try to make them look like 4s today. All right, so the answer is B. And we can move on. All right, this is a long one. A landscaping company estimates the price of a job in dollars using the expression that, where N is the number of landscapers who'll be working and H is the total number of hours the job will take using N landscapers. Which of the following is the best interpretation of the number 12 in the expression? Well, I see here that I'm multiplying 12 times the number of landscapers times the number of hours on the job. Okay, and this whole thing is estimating the cost. So chances are, if I'm multiplying that figure by hours, by landscapers, it probably means the price that I'm paying per landscaper per hour. So company charges $12 per hour for each landscaper. That's pretty good. Minimum 12 landscapers, nope. The price of every job increases by 12 every hour, nope. Each landscaper works 12 hours a day, nope. A looks to be good here. All right. Any questions you have, feel free to write in the chat. We are gonna jump along right here. Number 4, which of the following is equivalent to the expression shown above? All right, and we see we have a kind of complex polynomial here. And I noticed that the form of these is pretty much what we did on Tuesday, which is foiling, right? So if we have something like x plus y squared, right? What that means is x plus y times x plus y. And so in order to expand something like this, we use the FOIL method. All right, FOIL. And foiling involves first multiplying the first term times the first term, then the outer term times the outer term, so on and so forth. In this problem, we see that the first term is 9a to the 4th. So we're really looking for which one of these terms, if you multiply it by itself, will equal to 9a to the 4th. And we see in A, 3a squared times 3a squared is going to be equal to 9a to the 4th. So we know that A is the correct answer. All right, let's move on here. Okay, let me actually get my handy dandy notebook just to make sure I'm not leading you guys astray. Okay, here we go. Alrighty, number 5. If k is greater than 0 and x is equal to 7, what is the value of k? Alright, so we are trying to solve this equation involving a square root sign. Okay, and actually they tell us x is 7. So we can rewrite this 2k squared plus 17 minus 7, because x is 7, is equal to 0. And the way that you want to solve square root equations is you want to have the square root on one side and everything else on the other side. So in this case, I want to move this 7 to the other side. And how do I do that? Well, you do the opposite to both sides, as always. Plus 7 plus 7. This cancels out, and we get the square root of 2k squared plus 17 is equal to 7. All right, now what's the next step? Again, opposite. What is the opposite of square rooting? That's squaring, right? So we want to square both sides. We're going to square both sides. And what happens when you square a square root? It basically just cancels out like this. All right, so what you have left on the left side is 2k squared plus 17 is equal to 49. Okay, and this should be a little bit easier for us to work with now. And so now we just do regular algebra. Opposite on both sides, cross that out. 2k squared, okay, is equal to 32. We're going to divide by 2 on both sides, again doing the opposite. And now we have k squared is equal to 16. So if k squared is equal to 16, k can either be 4 or negative 4. All right, we have two solutions. However, they tell us that k has to be greater than 0. So in our case, we can get rid of the negative solution, and our only answer is 4. All right, Bob asked in the chat, Sven can shovel his entire driveway in 2 hours. His brother Bjorn can shovel the same driveway in 3 hours. If the two brothers work together at their independent rates, how many hours will it take for them to shovel the driveway? It's a popular type of problem. I guess you can categorize that as a work problem. All right, and I'll explain it later, but I'll just give you a hint right now that if Sven, I like the like Danish names here. If he could do the job in 2 hours, you want to consider how much they can get done in 1 hour, right? So if Sven can shovel his entire driveway in 2 hours, that means in 1 hour, he can get 1/2 of the job done. His brother, in 1 hour, gets 1/3 of the job done. All right, so that's my hint for now, and we're going to come back there to get the full solution for the problem. Alrighty, number 6. In the xy plane above, line L is parallel to line K. What is the value of P? Okay, so our goal is to find out, bam, right there. And so what do we know? We know that these two lines are parallel. And if two lines are parallel, we know that they have the exact same slope. So that's going to help us, right? This line has the same exact slope as this line. Okay, so what is the slope of our first line here? Well, we want to do rise over run. Okay, rise over run. So it's rising up. How much is it rising up? It's rising up 2, right? It's going up 2, and then over, it's running 5. So the slope for this one is 2 over 5. And if that's the case, that means the slope for this line is 2 over 5 as well. So what are we going to do? We're going to go up 2 here and run over 5. Okay, so this is going to be at at 2, negative 2. Okay, and then we're going to go up 1 more and run over, and that's going to be 4, that's going to be 4, comma 0. All right, because it's running up 2 and running over 5. Okay, and I said 2, negative 2. Oh no, sorry, I'm losing my mind here. This is 5, negative 2, and this is 10, 0. All right, because it's running over 5 every time. All right, that's my bad. So the answer to 6 is 10. Bam. All right, any questions so far? If not, I will move on. Let me take a little drink first here. This is a very popular type of problem. All right, anything that deals with exponents, you will usually have to either subtract the exponents or add them. So in this case, we see that x to the a squared divided by x to the b squared is equal to x to the 16. Okay, so how do we simplify right here? Well, we know when you divide numbers with the same base, okay, so we're dividing x to the a squared divided by x to the b squared. All right, what you do is you subtract the exponents. So in this case, you get x to the a squared minus b squared. Okay, and if that's equal to x to the 16, all right, how are we going to solve for a squared and b squared? Well, all we do is we know a squared minus b squared has to be 16. We know that, right? Because the base is the exact same thing, so the exponent must be the exact same. So that's why a squared minus b squared is equal to 16. All right, so if you've gotten here thus far, you're doing pretty well. All right, that's awesome. But next, we see that they give us a hint. A plus b is equal to 2. How does that help us solve when we have a squared minus b squared? Okay, and this is where I want you to remember the difference of squares. Okay, the difference of squares. Okay, and I promise my handwriting will get better over time. So how do you do difference of squares? If you see that you have a perfect square subtracting another perfect square, you could actually expand that. Okay, so a squared minus b squared is equal to a plus b times a minus b. And this is true of all perfect squares. If you see them in this form, you could always factor them to look like this. Okay, so how does that help us? Well, if we know that this right here is equal to 16, right? And they tell us that a plus b is 2. They tell us a plus b is 2. we know that this thing right here is equal to 2. So 2 times a minus b is 16, right? What does a minus b equal? Right? That's what they're asking us. What does a minus b equal? We know it must be equal to 8. All right? So this is a perfect example of how you can solve for variables, right, or multiple variables without knowing what each of them are. We don't know if a could be 10 and b is 2. We don't know if a is 12 and b is 4. All we know is that a minus b is equal to 8. Okay, so that's pretty powerful. Let's move on to number 8. All right, the measure a in degrees of an exterior angle of a regular polygon is related to the number of sides n of a formula above. If the measure of an exterior angle is greater than 50 degrees, what is the greatest number of sides it can have? All right, so pretty easy. So basically they're telling us that for any regular polygon, okay, so that means that any polygon that has equal side lengths and angles, that is the ugliest looking regular polygon ever, okay, but that's all it means, that all the sides are equal and all the angles are equal. It's basically saying that the number of sides times each exterior angle is equal to 360 degrees. So if an exterior angle is greater than 50, what is the greatest number of sides it can have? Okay, so let's see what it is if it's exactly 50 degrees. So if it's n times 50 is equal to 360, how many sides does it have? Well, I see here that we just do 360 divided by 50. Okay, we can cut off the zeros at the end. You could always do that. And then what is 36 divided by 5? It's going to be 7 point, all right, so subtract 35 here. And you drop down to 0, so it's going to be 7.2. So we know that if it's 50 degrees, the maximum number of sides is 7.2 sides. But you know we can't get to 7.2 sides, and it can't be 8, because that would be too great. So the maximum number of sides is 7. Okay? Very nice. That was pretty easy. I guess it tested your long division skills, because remember, this is a no calculator section. So you have to do all of your division by hand. Hey Bob, did you get the problem with the hint, the 1/2 plus 1/3? Let me know in the chat, and I can maybe take a little break and show you how to do that problem. All right, number 9. The graph of a line in the xy plane has slope 2 and contains the point 1, 8. The graph of a second line passes through the points 1, 2, and 2, 1. Okay, if they intersect at point AB, what is the value of A plus B? All right, so for these problems, how do you know, right, where two lines intersect? So let's say I have a line that goes like this, I have another line that goes there. How do you know at what point they intersect? Well, the easiest way to do it is if you have the two line equations for these two lines, all you have to do is set them equal to each other, and that will kind of reveal what the points where they actually cross. So our goal right now is to get the equation for each of these two lines. So for the first line, it has a slope of 2, and it goes through 1, 8. So if you recall the point slope, okay. All right, so you're close. We'll get to that in a second, Bob. So what is the point slope formula? It looks something like this. Y minus y1 is equal to m times x minus x1. And all we have to do is fill in an x coordinate, a y coordinate, and the slope. And lucky enough, we have all three in this case. So let's fill those in. Y minus 8 is equal to 2 times x minus 1. All right, and if we solve this, we get y minus 8 is equal, and we're going to distribute this right here, 2x minus 2. And lastly, we're going to add 8 on both sides, plus 8, and we're going to get 2x plus 6. So that is our first equation, y equals 2x plus 6. Our second equation, we know that they go through both of these points, right? And unfortunately, we don't have a slope, right? We have 2 points to choose from, but we don't have a slope. So what do? Well, all we do is we find the slope by using these 2 points. So how do you find the slope? We want to find out the difference between the y's and divide that by the difference of the x's. So in this case, we want to do 2 minus 1, right? I'm subtracting the y's over 1 minus 2. And be careful here, because you want to remember, if you're starting using this point, you must start using its neighbor right here, right? So if I'm doing 2 minus 1, I have to do 1 minus 2. I can't mix and match them, okay, because you're going to get the wrong side. So in this case, the answer is 1 over negative 1, okay, and the slope is minus 1 in this case. So the slope is equal to minus 1. So now we can do the same thing. We can do point slope formula, right? And I'll do it up here. Y minus 2, and I could pick either of these points. I'm just picking this one for fun, is equal to negative 1 times x minus 1. And I'm going to solve for this. So this is going to be equal to negative x plus 1. We're going to add 2 to both sides, and we're going to get y is equal to negative x plus 3. So now I have two equations. I have this equation and I have this one. And so now what do? I set them equal to each other. Okay, so I set my y's equal to each other. So I have negative x plus 3 is equal to 2x plus 6. 2x plus 6. And so now I'm just going to solve for x. I'm going to add x on both sides. And I'm going to get 3 is equal to 3x plus 6. Subtract 6. And I'm going to have negative 3 is equal to 3x. Oops. And now I'm going to divide 3, right? Because I want to do the opposite. What's going on? The opposite to both sides. And so I have x is equal to negative 1. And if x is equal to negative 1, how am I going to find out y? Right? How am I going to find out y? Well, look here. I have two perfectly good equations to choose from. I have either this one or I have this one. Either one, you should get the same exact answer. So I'm going to plug in negative 1 here, and I see I get y is equal to negative x plus 3. So that's going to be, or sorry, negative 1 plus 3. And that's going to be equal to positive 1 plus 3, which is 4. So if I have y is 4 and x is negative 1, combined, they're going to be equal to 3. So that was a pretty long problem, and I hope you stuck with me here. Remember, if you know the answer already, you could just go on and do it yourself. You do not have to wait for me. All right, but we are working through every single problem just in case somebody doesn't know. All right, so let's look at number 10. Which of the following equations has a graph in the xy plane for which y is always greater than or equal to negative 1? So this is kind of a fun problem. The way I like to think of this is, can you prove 3 of these wrong? Right, that's really our goal. Can you plug in an x such that y is not always greater than or equal to negative 1? That's our goal. Okay, so for this, in this case, I could plug in 0. If I plug in 0, I see that that is not greater than negative 1, so I can cross that off. What about this one? Let me plug in 0 again. 0 minus 2, that's also equal to negative 2. Right, so all I'm doing is I'm trying to plug in values that'll make these not greater than or equal to negative 1, and if that's the case, I know it can't be the right answer. Okay, and then I'm going to skip this one for a second because I see D, I could also plug in 0, and I will get negative 2 here as well, which is not greater than or equal to negative 1. And so C must be the correct answer. Nothing that you plug into X will ever make it less than negative 1. Okay. All right, number 11, complex numbers. And if you recall, a complex number is one that has a regular integer like this and something involving I. And I is an imaginary number, which is the square root of negative 1. Right? Ooh, imaginary. So how am I going to find out which of these is equal to 3 minus 5i over a plus 2i? Okay, so to solve this, right, what we want to do, okay, and I'm going to rewrite this here over 8. Okay, what we want to do is we want to multiply the numerator and denominator by 8 minus 2i. 8 minus 2i. Okay, and when we're simplifying these complex numbers, right, why did I choose 8 plus 2i? It's basically, or sorry, 8 minus 2i. It's basically just like the denominator, except with an opposite sign. And why is that so useful, right? This is going to come back to what we were talking about, wait for it, right here, this right here. We see that if we multiply something by its opposite sign, we can then use the difference of squares, right? So we're basically starting here, and we want to come back to something like a squared minus b squared. Okay, and I'm going to write that out one more time here. A plus b times a minus b is going to be equal to a squared minus b squared. So in this case, it's going to be equal to 8 squared, which is 64. I'm telling you, man, my 4s are abysmal. 64 minus 2i squared. Whoa, 2i squared. What is 2i squared? Well, that's going to be equal to 4 times I squared. And what is I squared equal to? Well, if I is equal to the square root of -1, I squared must be equal to -1, right? It's the square root of -1 times itself. So this is going to be equal to 4 times -1, which is -4. Okay, so in our case, it's going to be 64 minus -4. That's going to be our denominator. And our numerator, we are just going to FOIL, just like any other binomial. So FOIL, first times first is 24. Outer times outer is minus 6i. Inner times inner, I'm sorry, this is 5i, right? Yep. Inner times inner is minus 40i. Minus 40i. And last times last is -5i times -2i. So that's going to be 10i squared. Okay, and 10i squared is -10. Okay, -10. All right, you follow me so far? So then if I rewrite this down here, 24 minus 10, okay, 24 minus 10 is going to be 14 minus 6i minus 40i is going to be minus 46i over 64 minus -4. Okay, 64 minus -4 is going to be 64 plus 4, which is 68. Okay, so this is where we're at so far. If you're following with me, wait, my Windows is freaking out. Sorry guys. Okay, so if you're following me so far, all we have to do is separate this fraction into its individual parts. And so we're going to divide each of these by 68. So 14 over 68 minus 46i over 68. All right, and if we look, we see that this right here is equivalent to 46i over 6, or sorry, to our equation here. Okay, all it is they divided everything by 2. Alrighty, so maybe this is a good time to take a break. Maybe I want to check out a few of those SAT videos. I know we did a few on Tuesday. Still kind of brighten up the mood a little bit. You know, I don't want to be talking this entire time. Need some water. So let's check out some of these SAT tip videos. And after that, Bob, I'm coming back to you with the solution for your problem. All right? So let's see what we got in the ways of some recommendation videos. Let's switch. Oops. Let's switch to the TV screen right quick. Bam. And let's see what they have to tell us. Oh no.
Hey guys, it's Brooke with Super Tutor TV, and today we are going to talk about 3 math hacks for the SAT math section. If you haven't already done it, I just want to encourage everybody out there to subscribe to our channel. All you have to do is click the subscribe button. It's really awesome. Go do it. And then the other thing I want to encourage you to do is head over to our website, supertutortv.com. We have a blog and lots of other videos and blogs.
All right, let's get to it.
These are on the test. Sometimes the problem, the test. First hack is to use the answers. And
all right, we've seen this before.
A lot of tutors have probably given you, but I'm going to show you one way in particular that I use it on this particular test because of the nature of this test. This test is a little bit different from the old SAT and even the ACT in the sense that, one, the math section only has 4 answer choices. And a lot of the time, those answer choices have a lot of repetition going on in them. So when you see that repetition, that's a huge opportunity for speeding up. So I'm going to get into a problem right now. What I like to do with this particular trick is I like to save time, especially on the no calculator permitted section. There's usually a couple of questions where I can basically not necessarily do the problem all the way through, but look at the answer choices and sort of cheat my way to a faster endpoint, okay? So here's one problem where that's true. If y equals x cubed plus 2x plus 5 and z equals x squared plus 7x plus 1, what is 2y plus z in terms of x? As you can see, what we've got going on here is we've got 2 equations, and then we have what's called an expression here. I call these equation expression
Wow, her handwriting is much better than mine.
I'm going to use substitution. I'm going to plug in my z. I'm going to plug in my y into this expression. So this is a lot of adding. It's just combining. There's some FOIL, but I don't want to waste time. So I'm going to be a little smart, and I'm going to look over here. Whenever I'm combining terms, usually the easiest terms to combine are the first terms and the last terms. So those are what I'm going to look at first. I see that this is unique here, and then these are all the same. Do you see that repetition? And then over here, all of these are distinct except for the 2 11s. You see that? What I'm going to do is I'm going to go after, let's go after this column first, because I think that one's usually really easy to get, is like my no variable section. And so the way I get that is 2 times 5 is 10, right? If I use the distributive property, and then I'm going to add that 10 to the 1 over here. So that gives me 11. But you see how I'm not actually combining all my terms? I'm just being lazy and combining my last term and using process of elimination. So that gets rid of B and D.
You're pretty smart.
10 plus 1 is 11. Boom. And now, remember that first term? That first term is probably going to be pretty easy to solve out too. This is x cubed, right? This is x squared. Huh. So this has no x cubes at all. So my only x cubes are just these over here, which is going to be 2 times that, which is 2x cubed.
So this is actually similar to what we did with that FOIL problem, if you recall, where it was like 3x squared times 3x squared was 9x to the 4th. We didn't have to go through every single answer choice to know that we were going to FOIL eventually, and that's the only one that had 9x to the 4th. Right? So this is actually a useful tip that we saw on the test today. Let's continue. Maybe she has some more goodies for us.
Okay, so I need 2x cubed to C, and I'm done. Boom. Star.
So then next
answer, which is make up numbers. When you don't know how to do a problem, or even if you do know how to do a problem, a lot of times a way to build clarity or a way to figure out how all those numbers work together is to make up hypothetical numbers and plug those into the situation so that you can kind of play with things and know how everything is set up. This works particularly well whenever you have variables in the answer choice. So here's how this goes. The gas mileage for Peter's car is 21 miles per gallon when the car travels at an average.
All right, and we're actually going to do something very similar to this a little bit later in the test today. So this, I actually agree with her, is probably my top 2 tip on the exam. If you can plug in your own numbers, do it, because it's going to help you get to the answer much, much faster. So let's return to the math screen. Okay, and Bob, your time has come. You've been very patient, so let us discuss. I just need some space to work with it. And I guess I'll do it in here. So Bob's question, where'd my, I'm trying to use my drawing pad with my regular pen. Okay. All right, here we go. So Bob's question was, you have one brother, let's say Sven, who does a job in 2 hours. His brother, what was it, Bjorn does the job in 3 hours, how long does it take for them to do it together? This is a very, very popular type of problem. You can have any number of people doing any number of jobs in any number of hours. And it's pretty much solved the same way, right? So I want you to think about how much of the job can they each do in 1 hour. So in 1 hour, okay, in 1 hour, Sven does 1/2 of the job, okay? Bjorn does 1/3 of the job. Okay, so in 1 hour combined, if they're both doing the job, right, how much of it do they get accomplished? Well, in order to add fractions of different denominators, we know what to do, right? We want to set them both equal to a common denominator, which is 6. So we'll get 3/6 plus 2/6. Okay, so in 1 hour, if they work together, they get 5/6 of the job done. All right, but that's not what the problem is asking. They're not asking how much do they get done in 1 hour. They want to know how many hours does it take to do the whole job, right? So think about it. If they do 5/6 of the job in 1 hour, how many hours does it take? They're doing 5/6 per hour. So how much does it take for the entire job? Well, the entire job will be 1 whole, right? So we want to do 1 whole divided by how much they can do in 1 hour. And that will tell us how many hours it takes for them to do the entire job. So 1 divided by 5/6, all right? And remember, when you divide fractions, you do keep, change, flip. So we keep the first number, we change to multiplication, and we flip the fraction, okay? So 1 times 6/5 is going to be equal to 6/5, okay? And then we simplify 6/5 into 1 1/5. Okay, so it takes them 1.2 hours to get the entire job done. All right, Bob, I hope that helped. And you can pretty much do this exact same methodology for all the problems that ask you for work. Okay, this is going to be very similar for these types of problems. All right, and if you still have any questions, please let me know in the chat and maybe I'll take some time. And also for any new viewers out there, if you want to know exactly what time I'll be on, please hit the subscribe button, and I think you'll get like a little email or some sort of notification that tells you when I'm on. And then I can also give you a little shout out in the chat. You'll get like a little cute capybara pop-up. All right, so let's move on. Number 12, R equals F over N plus F. A website uses the formula above to calculate the seller's rating, blah, blah, blah. R is favorable reviews, F is unfavorable. Which of the following expresses favorable? Okay, so we don't really even need to know what any of these letters mean. All we want to do is we want to isolate F, okay, and have it equal something right here. So how do we isolate F? Well, it's actually not as easy as it looks, right? Because we have F in the numerator and denominator. All right, so maybe the first step that we can do is we want to get rid of this fraction. So if let me just rewrite this. R is equal to F over N plus F. In order to isolate this F in the numerator, I can multiply both sides by N plus F, because that'll help me get rid of this denominator right here, N plus F. Okay, so this cancels out and this cancels out. And so now I have N plus F in parentheses, and I have R multiplying that is equal to F. So far so good. But look, I have F on both sides, right? How am I going to isolate one of those? I just need to isolate a single F and have everything else on the other side. So in these types of problems, what you want to do is you want to distribute and get all of the F's on one side first. Okay, so in my case, I'm going to distribute R to both of these. So I'm going to get Rn plus Rf is equal to F. Okay, and remember how I said you want to get all of the F's on one side. So I'm going to subtract Rf minus Rf. Okay, this cancels out here, and so now you have Rn is equal to F minus Rf. Whew, so far so good. So this is the last step, and maybe the trickiest one of all. Well, now we have all of the F's on one side. What do? So the key here is you want to factor out the f from both of these. So you see how this and this right here, these two terms, both share an f? We can factor that out. So if we factor out an f, we see that what's remaining from this term? 1, right? F divided by f is 1. And what happens when you divide rf by f? You just have an r left. And so now we have f isolated, okay? And the last step is just to divide 1 minus r over 1 minus r. This cancels out. And so you have f is equal to Rn over 1 minus r. Woo! Very nice. All right, so for future reference, again, get all of the f's on one side, or all of the variable that you want to isolate on one side, and then factor it out. Okay. Number 13. What is the sum of all values of m that satisfy that trinomial there? Okay, so we're going to have to factor this, right? Because we want to get all of the values of m that make that equal to 0. And since it's a quadratic equation, we know there's going to be two values of m. Okay, so how do we solve this quadratic equation? Well, the first thing you should notice is that they all share 2, right? 2 is a factor of all three of these numbers. So maybe the first step we could do is divide everything by 2. Everything, so that includes the 0. So if I divide everything by 2, I'll get m squared minus 8m plus 4 is equal to 0. Okay? And now I'm here, and what do I want to do? I want to factor this. So usually I would see something that multiplies to this and adds to this. But in our case, there's actually no two numbers that will multiply to equal 4 and add to equal -8. And so what that tells me is if you can't use regular factoring methods, you must use the quadratic formula. That's the only way that you'll be able to get the factors here. Okay, and the quadratic formula is 0 is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and we see that a is equal to 1, right? So a is 1, b is -8, and c is 4. All right, so let's plug that in. So it's going to be 8 plus or minus the square root of 64 minus 4 times 4 times 4 times 1 is 16 all over 2. All right, thanks. So far so good. Just make sure my handy dandy handbook here. Yep, everything looks good so far. And so if I'm to simplify this, that's going to be 8 plus or minus the square root of 48 over 2. All right, and Bob, I hope you saw the solution to your Sven and Bjorn problem. If you have any further questions, hit me up in the chat. Okay, so how do we solve this right here? Right, we have to simplify the square root of 48. So I don't know if you guys have been taught how to simplify square roots, but your job is to find out are there any perfect squares that go into this square root? Are there any perfect squares? So I see that the square root of 16, okay, the square root of 16 is a perfect square times the square root of 3 equals the square root of 48. Ooh, all right, and so what's the square root of 16? That's going to be equal to 4. So 4 times root 3 is equal to 4 root 3. So you simplify the square root of 48 into 4 root 3. So let's continue now. So 8 plus or minus the square root of, 4 root 3 over 2. All right, and since we're dividing 2, we can divide it by both of these. So you'll get 4 plus or minus the square root of 2 root 3. All right, so what are we trying to understand? We know that m equals 4 plus 2 root 3, and it's equal to 4 minus 2 root 3. Both of those solutions are correct. Our job is to find out the sum of both of these values. So what is the sum of these right here? Okay, and we see that 2 root 3 minus 2 root 3 cancels out. Bam, get out of here. All right, so the final solution to this is just 4 plus 4, which is 8. Not too shabby. All right. This is maybe a little tricky, right? And I might have gone a little too fast. If I'm going too fast, please let me know in the chat, all right? Because sometimes I like get in the zone and don't realize how fast I'm going. All right, it's only the third stream. You know, we're getting better every single day. And Bob on Tuesday recommended using maybe some music in the background. If you guys think that music could be a nice touch, maybe hit me up with some recommendations. What sort of genres would be really nice for math? I'm thinking like either some sort of kind of light EDM, nothing too crazy, or maybe some light like hip hop beats. No words, just instrumentals. So that's what I have in mind. If you guys have any suggestions for music, let a brother know. All right, 14. A radioactive substance decays at an annual rate of 13%. If the initial amount of substance is 325 grams, which of the following functions models the remaining amount? So if you were here on Tuesday, you remember I taught simple interest, right, and simple rate. And this is actually done in the exact same way. All right, so this is the formula for simple interest. All right, and this is actually also the formula for growth and decay. All right, so in our case, P is what you start with. So you start with 325, okay? And what is the rate? Well, in this case, it's a rate of decay. So it's actually a -%. And the annual rate of decay is 13%. So what we want to do is 1 minus 13%. But since 1 is not a percent, right, it's a decimal, we want to change 13% to oops, sorry, 0.13, and we're going to raise it to t. Okay, so in this case, all we got to do is rewrite 1 minus 0.13 is 0.87. Okay, and if it was growth, if it grows 13% every year, then we would just do 1 plus 0.13. All right, in this case, it's decaying, it's going down, so we're subtracting. All right, so that should be our answer there. All right, let's move on. 15. So this is actually the last problem in the multiple choice section, which means it's quote unquote the hardest problem. And honestly, this one was really tricky. When I first looked at it, I'm like, what the heck are they trying to do here? And it was only when I saw 17 as an answer here that it got me thinking what they wanted us to do. All right. So really, you don't see it right away. And if you have done some of these problems before, you might see it. But really what they want you to do is get x plus 3 in the numerator so you can cancel them out eventually. So that's a little tricky, right? But the goal, again, is to get x plus 3 in the numerator somehow. And the way that you do that is you realize that 5x plus something, okay, you should be able to factor that out and get x plus 3, right? What can you add to 5x such that if you factor out the 5, you'll have x plus 3 remaining? And so in that case, we're going to be adding 15, all right? Because if you take out 5 from each of these, you get x plus 3 remaining. And so if you're adding 15, right, you have to subtract 15 also, because you want the numerator to not change at all. You want it to add kind of 0, right? So if we're adding 15, you have to subtract 15, all right? And then minus 2 is coming from right here. So that's really all I did. All I did was add 15 and subtract 15 in one step. And so what this allows us to do is factor out 5 in the numerator. So we get x plus 3 minus 15 minus 2, which is minus 17. And that's what kind of triggered. I was like, wait, they got 17? Did they like add 15 somewhere? So just because of that prompt, it kind of clicked. All right, so I do not blame you if you had to guess on this one. It was actually pretty hard to see. All right, and so now we have x plus 3. Okay, and so if you divide x plus 3 by both of these, you get 5x plus 3 over x plus 3 minus 17 over x plus 3. And in this case, x plus 3 cancels out. And so this is your answer here. All right, so do not feel bad or lose confidence because you couldn't get this one. It was actually one of the trickiest problems that I've seen on the test so far. All right, moving on to the short answer question. So you should be relieved to know that if you can get through those difficult problems, once you get to the short answer, they start to get really easy again. Okay, so my hint to you is once you get to these like teens problems, right? If you get to like 12, 13, 14, and they start to seem really hard for you, skip them, go to the short answer portion, do as many of those as you can, and then return back to the hard ones. All right, don't waste your time on really hard problems when really easy problems are coming up. You see? And definitely never leave anything blank. Okay, so if you're gonna skip it and come back later, remember to just circle something in. Do not leave any questions blank ever on the SAT. All right, number 16. The sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded in amounts of $250 or $750. If at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of $250 bonus awarded? All right, so that's pretty easy. We could just fill in our own numbers, and clearly there's multiple solutions to this. So they said at least one $250 bonus and one $750 bonus were awarded. So let's say, for fun, we want to say maybe two $250s were awarded and two $750s were awarded. Okay, so combined that would be 500, and this would be 1,500, and so that means 2,000 was awarded. Okay, and then that means that we have 1,000 left. Okay, and so let's see how many more 250s we can get from there. We know that in 1,000 we can get we get 4 more bonuses, 4 more $250 bonuses, plus our 2 initial ones. Okay, so in total, in this case, we have 6 $250 bonuses awarded. But obviously, you can get different answers if you chose, one $750. So it's a pretty easy problem, and you have multiple solutions for that. 17. So we see we have messy polynomial here. It says A, B, and C are constants. If the equation is true for all values of x, what is the value of b? So basically what they're saying is if these two are equal, right, what is the value of b? All right, so how do we solve that? Well, first thing you probably want to do is get rid of these parentheses, right? We want to expand these parentheses. So we're going to distribute this, and then we're going to distribute this. And so let's start here. 2x times 3x is 6x squared, plus 5 times 2x is 10x, plus 3 times 3x is 9x, plus 3 times 5 is 15. And now let's combine like terms. So we're going to get 6x squared plus 19x plus 15 is equal to ax squared plus bx plus c. And so if that's true, we see that 6 is a, 19 is b, and 15 is c. Right? And so if they're asking us what is b, b is equal to 19. All right, we can just match these constants up to their variable friends. All right, 18. In the figure above, AE, okay, this line here is parallel to CD, and segments AD intersect, okay. What is the length of CE? So the length of that right there. Okay. So first off, I'm sure you've seen problems like this. All right, and if you have, you know that these two are similar triangles. How do we know that these two are similar triangles? Well, first of all, we know that these angles are the same, right? Vertical angles are equal. And we also know that these two lines are parallel. Okay, so if they're parallel, that means that alternate interior angles are equal, right? So, so this is equal to this, and this is equal to that. Okay, and if all three angles are equal, then these must be similar triangles. And so we see that if these are similar, 5 is half of 10. So this right here, CB, must be half of 8. Okay, and so CB is 4. All right, and they're asking us for CE. 4 plus 8 will be 12. 12 units long. Very nice. Moving on, number 19. We're almost done. How many problems are there in total? Oh, are these the last two? All right, so these are the last two for the calculator section. And then we're going to take a small break and jump into this is the non-calculator portion, and we're going to jump into the calculator part. All right. So in the xy plane above, O is the center of the circle, and the measure of AOB is pi over A radians. So we want to find out what is the measure of this, because then we can find out what A is equal to. So let me actually just rewrite this triangle, right? So if you've seen these problems before, you know that we're dealing with sine, cosine, and tangent in some sort of way. Okay, so let me write out this triangle as such. Actually, do I have a line drawing tool? Bam, let's see this. Okay. Okay. Okay, that's good enough for me. And so we know that this is the angle we're interested in. Okay, think about it, right? This right here, the x is root 3, right? Because we're going root 3 to the right. So this right here is going to be root 3. And we're going up 1. So this right here is 1. All right, and if you know the special right triangles, you can use Pythagorean theorem to figure out that this is 2, right? A squared plus b squared is equal to c squared. And so this is a special right triangle. It's called the 1, 2, root 3 triangle. All right, and we know that the ratios of these angles are going to be 30 degrees, 60 degrees, and 90 degrees. All right, and if you don't know how I did this, let me know in the chat, and maybe I'll make a separate video on special right triangles. But this is a very famous one. So we know that this angle right here is 30 degrees, okay? Except it's in degrees, it's not in radians, right? How do we convert 30 degrees into radians, all right? The easiest way that I've remembered how to do this is that pi is equal to 180 degrees, all right? So pi radians is equal to 180 degrees. So pi over what will get you to 30? 180 degrees divided by what will get you to 30? And we know 180 divided by 6 is going to get you 30 degrees. So 30 degrees written as radians is pi divided by 6. And so A is equal to 6 for this problem. Boom, boom, boom. Last non-calculator question of the day. Let's do it, guys. In the system of equations above, A and B are constants. If the system has infinitely many solutions, what is the value A over B? All right. So how do you know if two equations have infinitely the same number of solutions? Right? If they're linear equations, what you have to realize is you have a line. So let's say one of these is a line that looks like this. Okay. if I have another line that looks like that, how many solutions are there? Well, in our case, there's only one solution, right, wherever they cross. How can you have two lines that have infinite number of solutions? So if I draw that first line again, how do we draw a second line where they have an infinite number of overlapping points? The only way you're going to do that is by literally drawing the same line. That doesn't let me do that. Okay, you draw the same exact line overlapped, right? So both of these lines are the exact same line. They're perfectly overlapped on each other. So in our case, both of these have to be equal to the same number. All right, we have to figure out what would they look like if they were the exact same line. And so in our case, we see that the second equation is equal to 60. So in order to match up the first one and make it equal to 60, we want to multiply the whole thing by 5. All right, because 5 times 12 will get us to 60. So if we multiply 5 by the entire equation, we get 5ax plus 5by is equal to 60. And let's write the other one underneath. Okay, 2x plus 8y is equal to 60. And so if this is the case, we know that 5a must be equal to 2, and 5b must be equal to 8, right? They're the exact same equation. So it's no mystery that 5a is equal to 2, 5b is equal to 8. All right, and so let's solve for a. A is equal to 2/5. B is equal to 8/5. Okay, and I just divided 5 here, and I divided 5 on here. And so what is A over B? What is going to be 2/5 divided by 8/5? Well, we can do the same thing we did before. Keep, change, flip. We're going to keep 2/5. We're going to change division to multiplication, and we're going to flip the second fraction. All right, that's how you divide two fractions. And so we're going to get 10 over 40, which is equal to 1/4. And if you stuck with me this entire section 3 of practice test 2, all right, you should be confident in your non-calculator abilities. There was a big range of questions here, and if you were here on Tuesday, you saw that there are a lot of similar questions from test 1 to test 2. And I promise, if you can do all 8 exams and you understand how to do each of those problems, there's pretty much nothing they can throw at you that'll surprise you. Almost nothing. Okay? So let us take a short break. All right, and I'll be back in about 5 minutes. In the meantime, maybe I'll turn on some of these YouTube videos. Let's see. Let's search for something good. What will help you? SAT math. Tricks. Okay. Hard SAT. Yeah, here, why don't we turn on the angles, arc lengths, and trig functions from the Khan Academy math, SAT math. So let me turn on my snazzy movie, bam. And so we're watching the Khan Academy angles, arc lengths, and trig functions.
What is the length of arc ABC?
All right, and I'll be right back.
ABC is this arc right over here. And the reason why they have to give us 3 points, because if they just said arc AC, it would still be ambiguous because there's 2 arc ACs. It could be this arc right over here, or it could be this arc over here. And so when they tell us B, we know that we're going from A to C through B. So that's why this kind of, by giving us that third letter, it resolves the ambiguity on which arc we're talking about. So what is the length of that arc? Well, the first thing we could do is, well, let's just think about the entire, what's the circumference of this circle? And then we could say, well, what fraction of the entire circumference is this arc. And a big hint here is if we were to go all the way around the circle, that would be 360 degrees, but we're only going 135 of those 360 degrees. But let's first think about the circumference. So the circumference of a circle is equal to 2 pi times the radius of the circle, and they give us the radius is 3 inches. So the circumference is going to be 2 pi times 3 inches. So times 3 inches, or 2 times 3 is 6 times pi, so it's going to be 6 pi inches. Now, and actually if you look at the choices, over here, the entire circumference of the circle is 6 pi inches. And remember, pi is 3.14159, so this is going to be something in the, it's going to be a little bit over 18 or 19 inches. And so you could immediately, if the entire circumference is a little over 18 or 19 inches, this is only a fraction of that entire circumference. So actually, if you even were looking at the choices, you'd say, well, hey, these are way too large. But actually, let's see if we can get to the exact right answer. So the entire circumference is 6 pi inches, but this arc length isn't the entire circumference. It only goes 135 degrees out of 360 degrees. So we could say, so it is 135/360th of the entire circumference. Remember, if we were to go all the way around, that's 360 degrees, while this angle right over here is 135 degrees, the angle that is subtended by this arc. So this arc length is going to be 135 out of 135/360ths of the entire circumference. So times 6 pi inches. So let's see if we can simplify this a little bit. So let's see, 300, we could divide the numerator and the denominator by 6. 6 divided by 6 is 1. 360 divided by 6 is 60. And let's see, if we divide 135 by 5, that is going to be 27. Yeah, 100 divided by 5 is 20. And then 35 divided by 5 is 7. So this is going to be 27. And then this would be 12 if we divide 60 by 5. And let's see, we could then divide we could divide the numerator and denominator by 3. 27 divided by 3 is 9, and 12 divided by 3 is 4. So we're left with 9/4 times pi inches. So 9/4 times pi inches, or we could multiply the numerator times the pi. We could say 9 pi over 4 inches. And when you look at the choices, that is this one.
Obviously my mic was off and I just talked to myself, but I was saying how Sal Khan is online tutoring God, so I quiver in his audio presence. And also his handwriting is so good on stream, or however he does it on recorded video. I gotta practice the handwriting somehow. But to be fair, my IRL handwriting is terrible, so I guess stream handwriting won't be that much better. But I will try for the sake of your eyes. That's the least I could do for your support. Okay, so let us get back to the math screen. And we are going to scroll down to section 4, which is the calculator section. Yes. So that means the questions are going to be a little bit harder, right? Because we have the beauty of or access to a calculator. And we're probably not going to get through this entire section. So I remind you that the next stream is going to be on Sunday at 7 p.m. Eastern. And the stream schedule, as always, Sunday, Tuesday, Thursday, 7 p.m. to 9 p.m. Eastern time. That is New York time. All right, and if you want to have a reminder of when I'm on, because maybe sometimes I'll go a little early for the subscribers. If you guys want to do a little Q&A, hit the subscribe button, and then you'll get a reminder as soon as I'm on. Okay. Well, actually, where are we with the subscriber goals? I kind of haven't really talked about that. So we are currently at 8 subs, which is awesome. Just started about a week ago. So this is the third stream. The goal for this month is 20 subscribers, which is not that much. All right, so tell all your friends, all your homies, whoever wants to get a 2400. Okay, I can't promise you're going to get 2400, but to do a lot better than you would without some stream help, tell them about the channel. Oh, I could do that. Bam. Alrighty. Number 1. A musician has a new song available for downloading or streaming. The musician earns 9 cents each time the song downloaded and $0.002 each time the song is streamed. Which of the following expressions represents the amount in dollars? So this is pretty easy. It's 9 cents per download. So it's 9 cents times D. So we can knock off these two. Plus $0.002 times each time it's streamed, which is S. And so it's not going to be subtraction, right? You're not losing money every stream. You're gaining money, so it's going to be C. 2. A quality control manager at a factory selects 7 light bulbs at random for inspection out of every 400 light bulbs produced. At this rate, how many light bulbs will be inspected as the factory produces 20,000 light bulbs? So this is kind of like a proportion problem, right? We know that 7 out of 400 is checked, okay? And so the question is, what if, how many will be inspected if the factory produces 20,000? So if we want an equivalent proportion, we know that we have to multiply the same number here and the same number here. So 400 times what is 20,000? 400 times 50 is 20,000. So 7 times 50 will be 350. All right, so 350 is our answer. And we can fly through this. One end of a spring is attached to a ceiling. When an object of mass m kilograms is attached to the other end of the spring stretches to a length of L centimeters, blah, blah, blah. What is m when L is 73? So that is the key question. When L is 73, all right, and I'm replacing 73 for L, what is m going to be equal to? So this is a fairly simple algebra problem. How do we isolate m? Well, what you want to do is you want to do the opposite to both sides. And one day I'm going to have a shirt that has a cute little slogan for opposite and both sides. I'm still thinking about it, so if you have any recommendations, let me know in the chat. So opposite on both sides. I'm going to subtract 24 on both sides. This gets crossed out. 73 minus 24 is 49, I think. Okay. Equals to 3.5 m. And again, what is the opposite of multiplying by 3.5? Dividing by 3.5. So we're going to divide on both sides. This gets crossed out. So what is 49 divided by 3.5? Let's use the handy dandy calculator. 49 divided by 3.5 is 14. That's simple enough. 14 is our answer. Number 4. How much money will the performer earn when 20 people... Oh wait, I did not even read this top part. Okay. The amount of money a performer earns is directly proportional to the number of people attending the performance. The performer earns $120 at a performance where 8 people attend. Okay? So this is a direct proportion problem. So if you recall, the equation for direct proportionality is y equals kx. And k is our constant of proportionality. So we probably want to find out what k is first before, because once we know what k is, we can plug in anything for x and it'll tell us what our y is. So in our case, the performer earns $120, okay, and 8 people attended, right? So in order to find out k, we set up the equation as such, and then we isolate k by dividing 8 on both sides. And what is 120 divided by 8? Right? Divided by 8. 15. So k is equal to 15. So now that we have our new equation, y is equal to 15k, or sorry, 15x, we can plug in anything for x, and it'll tell us. We can plug in any number of people attending, and it'll tell us how much the performer earned. So in this case, we have 20 people attending. So y is equal to 15 times 20. And we know that 15 times 20 is 300. Number 5. The performer uses 43% of the money earned to pay the costs involved in putting on each performance. The rest of the money earned is the performer's profit. What is the profit the performer makes at a performance where 8 people attend? So if 43% is cost and the rest is profit, right? How much is profit? Well, 100% is total minus 43% is cost. So 57% must be profit. Okay, so 57% is profit. How do we find out what 57% is of $120, right? Because they said if 8 people attend, he makes $120. So how do we find out 57% of $120? Okay, so percent of problems are pretty much all done in a similar fashion. All right, the way I like to do them is I like to translate them into the language of math. Okay, so of in the language of math pretty much just means multiplication. 120 is 120. And how do we translate 57% into a decimal? Because we cannot multiply 120 by a percent. We want to multiply it by a decimal. So the way that you convert a percent into a decimal is you move the decimal place 2 times to the left. Okay, so our new decimal place is right there. So we get 0.57 times 120. 0.57 times 120. $68.40. It's not a lot of money, but listen, I'm sure he's early in his career. All right, he'll probably have 1,000 people attend the next show. So maybe you can figure out how much money, how much profit he would make if 1,000 people attended his next gig. But I hope he grows his audience. Number 6, when 4 times the number x is added to 12, the result is 8. What number results when 2 times x is added to 7? So in this case, we also want to translate this into the language of math. Okay, so 4 times the number x, aka 4 times x, aka 4x, is added to 12. The result is 8. All right, so we just translated that into Mathanese. What number results when 2 times x is added to 7? So we want to find out what is 2 times x plus 7. That's pretty easy, right? If we can find out what x is equal to, then we'll just plug it in here. Bada bing, bada boom. All right, so let's do that. So let's subtract 12 on both sides. Opposite on both sides. All right, and we get 4x is equal, 8 minus 12 is negative 4. And then what's the opposite of multiplying by 4? Dividing by 4. So we're going to divide that. We're going to say x is equal to negative 4 divided by 4 is negative 1. And so now that we know what x is equal to, we can plug it in here. 2 times negative 1 plus 7 is equal to negative 2 plus 7 equal to 5. Bam. And we're freestyling this. My answer key is somewhere over there. I'm too lazy to get it right now. So if I have any mistakes, you can just write a nasty comment and just say I'm dumb or something. All right. 7. The equation above represents a parabola in the xy plane. Which of the following equivalent forms of the equation displays the x-intercepts of the parabola as constants or coefficients? So when you factor a quadratic equation as such, if you want to show the x-intercepts, you actually want to put it in a form that looks like this, okay? Because this will show you that x, or that the parabola is like this, that the parabola goes, it's going to look something like that, all right? 2, 4, all right? So, wait, what? That's not a 4? 4, okay? So this form right here shows you that the intercepts, one of these is located at positive 2, and one of these is located at positive 4. So D, in our case, is the solution, right? Some other forms are familiar here, like this is the beginning to vertex form here. This is standard form, okay? So in this case, this is the kind of x-intercept form of the quadratic equation. Number 8. In a video game, each player starts the game with K points and loses 2 points each time a task is not completed. If a player who gains no additional points and fails to complete 100 tasks has a score of 200, what is the value of K? So let's try to translate these rules into some sort of equation. So it starts the game with K points. Starts the game with K points, and then loses 2 points for every task that's not completed. And so we'll say T is every task that's not completed. So it loses 2 points, okay? And that's going to be equal to, let's say, our final score, okay? So K is our beginning. 2 for each mess up is equal to S. All right, and so the question is, fails to complete 100 tasks, okay, so T is equal to 100, has a score of 200, so the final score is 200, okay, what is K going to be equal to? So we can solve that. We'll just plug in 100 for T, and we'll set S to 200, and now we'll just solve for K. K minus 200 is equal to 200. We're going to do the opposite to both sides. So we're going to add 200 to both sides. Okay, and so K is going to be equal to 400. Bam. Alrighty. So let's see how many questions do we have left here. Okay, so in the short answer in the multiple choice portion, there are 23 questions. Okay, and we are on question 9. So I'm going to go until question, let's see, let's complete the next 2 pages, and then we'll cut off the stream for today, and we'll resume on Sunday at 7 p.m. with the exciting conclusion of practice test 2, section 4. Bam, the calculator portion. Okay, number 9. A worker uses a forklift to move boxes that weigh either 40 pounds or 65 pounds each. Let X be the number of 40-pound boxes and Y be the number of 65-pound boxes. The forklift can carry up to either 45 boxes or a weight of 2,400 pounds. Which of the following system of inequalities represents this relationship? Well, we know that if X is the number of boxes, number of 40-pound boxes, and that's that, and Y is 65-pound boxes, then X plus Y have to be all of the boxes, right? So X plus Y have to be less than or equal to 45 boxes, right? We know that. So we can knock off this one and this one, right? Because we need to see that X plus Y, my lines are bad, X plus Y is less than or equal to 45. And so lastly, we want to see that there's a max weight of 2,400 pounds. So for every 40-pound box, we want to multiply by 40. And for every 65-pound box, we want to multiply to 65 to get the total weight. And combined, the total weights must be less than 2,400, less than or equal to. So in our case, A is the correct answer. Number 10. A function f satisfies f of 2 is equal to 3. And remember, this is not f times 2. This is f of 2. We're dealing with functions. So f of 2 is equal to 3, f of 3 is equal to 5, g of 3 is equal to 2, and g of 5 is equal to 6. So what is f of g of 3? Well, this is what you would call a composite function. And a composite function is one where you have a function inside of another function. And this can go on infinitely. You could have functions inside of functions inside of functions. And the way that you deal with these is you usually want to work inside out. So we want to start with the innermost function, figure out what the output of that one is, and then plug that output into the input of the outermost function. So it sounds a little confusing, and I guess my English no good, but let's see if we can see it in the paper. So we see that the innermost function is g of 3. What is g of 3 equal to? Well, we see that g of 3 is equal to 2, right? So the output of g of 3 is 2. So now we want to plug that output into the input of f, right? Because the output of g of 3 is 2. And so now what is f of 2? F of 2 is equal to 3, right? So that means that our entire composite function is equal to 3. And it's important that you do the innermost first before the outer, because you're gonna get totally different answers. You might have gotten 5 if you did it backwards. Okay, so remember, you wanna go from inside to outside. All right, numero 11. Tony is planning to read a novel. The table above shows information about the novel, Tony's reading speed, and the amount of time he plans to spend reading the novel each day. Tony reads the rates given in the table. Which of the following is closest to the number of days it would take Tony to read the entire novel? So how many days would it take him to read the entire novel? Okay, so we see not all of this information is important to us. We basically want to find out, okay, let's see what's important. The total number of words in the novel is pretty important, because we also know how much he reads, how many words he reads per minute, and we know how many hours he reads per day. So using these three, we should be able to find the solution. So how many days would it take for Tony to read the entire novel? Okay. So he reads per minute 250 words per minute. I'm going to put words per minute. Okay. And so how many does he read per hour? Because we know how many hours he reads per day. So per hour, he reads, all right, 250 times 60, right? Because if it's 250 per minute, there are 60 minutes in an hour. So 250 times 60 will be 15,000 words per hour. And now how many hours does he read per day? He reads 3 hours per day. So we want to multiply this by 3, and we see that he reads 45,000 words per day. So far, so good. All right. And lastly, we want to figure out how many days would it take him. So if it's about if it's 349,168 total words in the entire book, divided by 45,000 words per day. Let's get my handy dandy notebook or calculator. 349,168 divided by 45,000. And so we see that it would take him a minimum of 7.76 days. But we're asking for whole days. So if it takes him 7 days and some, it'll have to take him 8 days total to read the novel. All right, or 8 whole days. Very nice. That was actually a good one. I like this problem because it's representative of the new SAT, whereas the old SAT just kind of had very obvious graphs and this is the data you need with this. The new SAT is trying to get students to critically think a little bit more. Like, which of these data points is actually important, right? We don't need to know the number of pages in the book or the number of parts in the book. So this kind of helps students think about what data points are important and how do I use those to get the solution as quickly as possible. So I'm a fan of that problem. Number 12. On January 1st, 2000, there were 175,000 tons of trash in a landfill that had a capacity of 325,000 tons. Each year since then, the amount of trash increases by 7,500 tons. If Y represents the time in years after January 1st, 2000, which of the following describes the set of years where this landfill is at or above capacity? At or above capacity. Okay, so we basically want to see which of these equations starts with 175,000, right? Because that's where we started, plus every single year we add 7,500 per year. So I see D shows that we started with 175,000 plus every single year we're adding 7,500. So 7,500 times the number of years. And that will show us when we are at or above capacity. Okay, so D is perfect. Oh man, 2 more problems left. Let's do it. For today, don't worry, don't freak out. We're coming back Sunday. That's going to be July 14, 15, 16, I want to say. July 16th at 7 p.m. Eastern. Okay, so if you want to tune in, come by on Sunday, and I promise we will complete this exam and maybe do even a little bit more. And also, if you're watching this at some other time, it's totally okay. You don't have to view it live. You know, I understand you're going out with friends, hanging out, eating dinner, going to the movies. It's all good, right? Study whenever you can. But in the comments, if there is something specific you want me to touch on in the next stream, please just mark that down. So comment, or if there's even a whole different topic. Maybe you're not into SATs, you're into ACTs, or maybe you want some help with trig. If there's something that you're stuck on, write that in the comments. And if there's a lot of demand for a certain topic, I don't have to be doing SATs the entire summer. I can move on to something maybe more relevant and higher in demand for you guys. So just let me know in the comments, and if you want to hit subscribe, then you'll know exactly when I'm on. All right, I might be on a little bit early and do some subscriber Q&As, so it could be worth it. 13. A researcher conducted a survey to determine whether people in a certain large town prefer watching sports on television to attending the sporting event. The researcher asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following factors makes it least likely that a reliable conclusion can be drawn about the sport watching preferences of all people in town? So what about this entire experiment makes it really bad? Well, if you think about it, this person is trying to research whether people watch sports on TV or go to sporting events. So maybe by asking everybody in one, like people, everybody who's asked were in a local restaurant, maybe those people tend to leave their house more. So maybe they would be more likely to go to a sporting event than people who order in. They order seamless to their house, they're chilling, watching on their TV, right? So clearly the issue here is that everybody that was sampled in the same local restaurant. So the issue is where the survey was given. All right. Apart from that, 117 people, that's a decent sample size. Like anything above 30 is okay. Population, we don't really know. And the number of people who refused to respond, it wasn't that many. It was only 7. So our sample is actually still pretty good. It's just the fact that everybody's in one little restaurant. So that might skew the data. All right, the last question for the stream today. According to the line of best fit in the scatter plot, which of the following best approximates the year in which the number of miles traveled by air passengers in country X was estimated to be 550 billion? Note that the Y axis here is in billions. All right, so this is 600 billion, 500 billion. So we're basically finding out where on this does it equal 550 billion, which is right there. Right there. So we're going to go across. So right here, and now from there, we're gonna come down right about here. So right there is just under 2005. So around 2004, 2003 is what we're looking for. 2003, perfect. You know, it would have been really annoying if 2004 was a answer choice, but they're pretty nice on the SATs. And this is actually why, or sorry, the College Board. This is why I recommend College Board official tests, because people maybe at the Princeton Review or Kaplan might not realize that putting those so close to one another would be, you know, unwise. But College Board is usually really good at that. All right, so I recommend almost exclusively doing College Board approved official tests when you're studying for the SAT. So yeah, so that about covers it for today. If anybody in the chat still has any questions, please ask now and I'll answer them live on stream. Otherwise, feel free to comment. I do look at the comments for these videos after I'm done, and I can answer them. I could take some time in the next stream to answer them, maybe first and foremost. So if you want to just jump into the next live stream, I'll answer your questions right off the bat. All right. So let's see. The lighting looks okay here. I like maybe like a little blue because I think the lighting is cold lighting. Here, you know what? What if I time out? I have like this little sheet I can put over the light. Let's see if that actually makes the color a little bit better. 1 second. Let's find that thing. Still looking for it, can't find it. Where the heck did it go? All right. Maybe I'll test it out on the next stream. I won't bother you right now with it. But yeah, thank you for tuning in. And if you want to subscribe, you can help me reach the monthly goal. And oh man, maybe I'll do like a little monthly goal sort of celebration. If we can reach 20 subs by August 1st, 2017, I'll think of something. Maybe I'll do like a random drawing of something really cool. So in the comments, maybe write down what you want to win. That could be cool. All right. So thank you so much for tuning in, and I hope that you're genuinely learning some SAT tips, some algebra geometry tips, okay? Because I'm really doing this for you guys. I want you to get better every single test, and I want you to go ahead without me. You don't want to wait for me to work on every single problem for you to do them. All right, so I suggest do the rest of the test by yourself, come back on the next stream, and just verify that everything was correct. All right, thanks so much. I'll see you on Sunday.